The question is saying that there are n meetings rooms we have given, and which is numbered from 0 to n minus 1, means number of meetings we have given is n, and your task is to like what are the given things we have given is another, apart from the number of meetings, you have given the list of meetings also, like, and that has been given a start and end. So each meetings have a start and end, right? What is our goal? Our goal is to find, right, for each meetings we have to assign it to the lowest number available rooms, and if no room is free, until that we have to wait when a room becomes available. Then the delay the meetings keep its original duration. Can we say that? Yes. So after scheduling all meetings, we have to return the room that had the most meetings, right? Means what is our goal? Our goal for each meetings, we have to assign it to the lowest numbered available room, right? So if the no room is free, we have to wait until a room becomes available. Then the delay the meeting keeps its original duration. After scheduling all meetings, we have to return the room that had the most meetings, right? So in very simple words, we can say what is the meaning of this. Means you have n number of meetings rooms we have given from 0 to n minus 1, and you have given a list of meetings, we can say that, right? And you need to assign the meetings to room based on a specific rules. Okay, so what are the rules are there? So rules are for each meetings that we want to start at some time, right? That is given at start time, and we have to pick the lowest number available rooms at that time, right? If no rooms are available, you must wait until one gets free. Then we have to reschedule the meeting with the same duration, right? You have to reschedule, right, until that we are not getting free, the rooms are not getting free, right? Until that once it is free, just to reschedule with the same duration. You will not change the duration of the meetings. Okay, when the multiple meetings are waiting, pick the one that wanted to start earlier. Then we have to return the room that handles most meetings, right? If tied, right, we have to return the smallest room number. I hope you understand, right? Means very first what we need to do, always choose the lowest number room, right? If room is available, delay the meeting to the time, and when any room becomes free, keep track of how many meetings we have here, right? So what is our idea to solve the problem, right? The very first, we will use mean heap, that is called priority queue, for the available room numbers. So this mean heap will use for busy rooms, right? And ordered by the meeting and end time. We'll sort the meeting by start time, and we'll allocate the earliest available room if no room is free. Until that, we have to wait for the room that becomes free earliest. Understand? So what is the meaning of this, right? Meaning is we are going to use a mean heap to track available rooms, right? Means by the room number, right? And the busy room means by end of the time of the current meetings. Okay, so let's understand. We have given this example n equal to 2, and meetings we have given like this, right? So if we'll say room 0 is what are the rooms I've given? We have given rooms n equal to 2, means room 0 and room 1, right? So these are the meetings we have given. Let's suppose, so meeting 1 is start from 0 and ends at 10. Meeting 2 start at 1 and 5, right? So both are independent, we can say that. There is some overlapping between them, but both are independent, you can say. So if meeting first started, right, means there is one room is free, either of this we can take, right? Let's suppose we are taking room 0. So room 0 is assigned to this meeting, right? Then for the next meeting 1 5, what is available? Room 1 is available right now, right? So both are free. So as you can see, so 0 and 10 assigned to room 0 because it's free, right? Then 1 and 5 assigned to room 1 because it's also free, right? Now the problem is begins from here, 2 and 7, right? So if we will take this meeting, third meeting, right? So we have to check both rooms are busy, right? Means we have to wait, correct? We have to wait. Now check room 1 becomes free at what time? At 5, because the end time is 5, right? So we'll say room 1 becomes free at 5. Okay, means we have to reschedule here. right? And we'll say the duration is what, 1 to 5, right? Means 5 unit, you can say, right? So we'll reschedule here. I will say start at 5:10, not to not to 2:07, right? From 2 to 7, sorry, 7 minus 2 is 5, right? 5 unit. So when we reschedule this meeting 2 and 7, we'll say 5 and 10 because ends at 5, correct? So we'll start this meeting at 5, right? And the duration is 5, so just do plus 5. Let's suppose we'll do 5:10. So room 1 is rescheduling for this meeting. Okay, now we have the last meeting is 3-4. So this meeting is going to end at where? At 10. This is also going to end at 10, correct? Means for 3 and 4, that this meeting, still no free rooms are available, right? Because it's occupied. This meeting, this room 0 is already occupied, and this room has been updated now, right? This become what? 5 and 10. Can we say that? Means this meeting, means room 1 will get free at 10, and room 2 will also getting free at 10, right? Can we say that? Means still no free rooms are there. Room 0 becomes free at time 10. Can we say that? So what we can say, so room 2 we have already handled 2 times, right? Room 2 we have handled 2 meetings, we can say. Now let's suppose both are going to ends at which room, we can say at 10, right? Both ends. So let's suppose we'll go with the lower number. What is the lower number? Or you can say we have to take the smallest index one, right? So let's tell this one, right? This is the smallest one. So what we will say, room 0 is also going to finish at 10, and room 1 is also going to finish at 10. It means we can take room 0, right? From when room 0 is getting end, that is at 10. So what we will do, because both ends at 10, so what we will do, 10 from 1 hour, right? Our 3 to 4. So this 3 to 4 we have to reschedule to 10 and 11 in room 0. Can we say that, right? So as a result, room 0 also handles 2 meetings, room 1 also handles 2 meetings, right? Because we have to give the priority of either of them, right? So we'll say we are giving the priority to room 0, because that will say, right? So room 0 is also free and room 1 is also free. So we have given both equality, and we'll say room 2 finish 2 meetings and room 1 finish 2 meetings, right? Means if you say how many, both, if who is wins, means nobody wins, this is tied, right? So we'll return the smallest room index, that is 0. What is the smallest room index? That is 0, right? So we'll return the 0. So the question is saying that we have given the number of rooms, and these meetings we have given, means we have to allocate the number of meetings to the rooms. Okay, so let's suppose in the real life what happens, you are a receptionist, right, who always tries to give the meeting to the lowest available room, right? If no rooms are free, makes the meeting wait, right, until some room frees up, and then schedule it with the same duration that we have seen for 2-7 and 3-4 we have seen. Okay, so let's suppose if you want to see the visualization, let's suppose we are talking about this is 0 and this is till 11, right? That we have understand. So meeting, no, we know that meeting 0 start from 0 and ends at 10 here, right? At here room meeting 2 is start from 1, it ends at here, right? 2-7, so 2 will come here, right? But if you see the no rooms are available, not free, right? So you can understand from here. Okay, so what we'll do, we'll start at where? At 5:10, right? So because this meeting is getting finished at here at 5, right? So we'll start from here and ends at 10. Like that we'll go for 3-4 and rest of the thing that we have seen. Okay, so total we can say that there is 2 meetings and both are done. Both meetings will get finished like this. Okay, both are done. Okay, so let's understand the code, how to implement this. So as we understand that example, right? So what we are doing, let's understand from here. Okay, so we are simulating a meeting room, right? Meeting rooms, you can say system. We are going to use priority queue, that is called heap, right? As we know. And so the heap will having the concept of available room, as you can say, right? Available rooms will be there, right? And these available rooms will store the available room number, right? And so that what we need to do, we'll create the priority queue, as you can see here, right here. Very first we'll do the priority queue. Okay, so the concept is to use the priority queue. So we'll use two priority queue heaps, right, for the available rooms, and another will use for we can say busy rooms. Okay, two things will store. So this available room store the available room number, that always gives you the smallest room number first, and this busy room will give you we will store first the, you can say, end time, right, and the room number. Okay, those two things will store. So this will be the pair, right, and it will store by sorted order by the when the room becomes free. Can we say that? So two things we will store. That is why, as you can see here, we have taken two things. First, the available room and the busy room. We'll talk about this one, what we are doing here. Okay, so very first, understand what is we have given. So this is our main function that will do what? It will takes number of argument, that is n, and meetings means n is number of rooms, and meetings is the array of start and end time of the meetings, we can say, right? So what we will do, very first we'll do the sorting. You know how to do the sort, array dot sort. We'll use meetings a and b, and we'll do integer dot compare, and we'll pass to you can say meetings. So this a at 0 and b at 0 will be the meetings. Okay, and these meetings we will meeting 1 we can say, or meeting 2, will compare it and will sort by their start time, right? Will with the help of start time. So at 0 will be the you know the meetings, right? So if we'll take one of the meeting here, right, so it will have what? Start and end, right? So if we'll treat this, let's suppose, as a, so at a0 it will be the start, right? Can we say that? And so we are doing here a0 and b0. So a is meeting a and b is meeting b. Can we say that, right? Give me 1 second, let me clear it. Okay, so first of all, what we have to do, we have given this main function we have given, and we have given meetings we have given, and we will sort it by the start time. Then we will do what? We will take the heap, we will take, and we'll take this what we call busy room, available room and busy room, right? So there is you will say why we are going to sort it like this, right? Because we need to handle the meetings, right? Why we are doing the sorting right here? Because we want to handle the meetings in chronological order, right? So that we can understand, when we'll do the sorting by the room number and the, you can say, available rooms, right, it will be easy for us, right? So next, what we going to use, we'll use these available rooms, where we will use the loop and we'll add all the given rooms as available. So initially all the rooms are available, as we have seen, room 0 and room 1 both are available initially. So first meeting came, it's available, occupied. Meeting 2 will come, it will be occupied, because both are free. Can we say that, right? So this is a kind of as a mean heap that will store the available room, right? So we'll initialize the room number, let's suppose, from 0 to n minus 1. So this loop, let's suppose n equal to 2. It means this will go 0 to 1, means 0 and 1, means this I will be at 0 and 1. So two rooms will be added on the here. Okay, I hope you understand. Okay, then we want to when we want to assign a meeting, we always use the lowest number room, right? And that is why we'll take 0 to n. Fine. Let's understand the, you can say, busy room, right? So this is also a heap that will store the room, right, that are currently busy, right? And for that, for each entry, let's suppose we'll call as a end time, you know that, end time, and another will be the room number, right? Room number. Two things will be there at each entry. Okay, so this room will take what? We will check, we'll sort it by earliest end time. This is our end time. So a at, let's suppose a at 0 we can say, is having end time, and B at 0 also having n times. This is meeting, let's suppose 0, and this is meeting 1. Okay, can we say that? So meeting 1 when it is getting finished, and meeting 2 when it is getting finished, you know the end time, right? Based on that, we will make it free. When the room is getting busy, we can understand that. So we can say this heap, that is busy room, will store the rooms that are currently busy, and each entry is having end time and the room number. So we'll sort it by earliest end time, right? And we'll do the sorting like this. Okay, so if two rooms ends at the same time, what will happen? We'll use the smallest room number. Okay, and for that, what we need to do when we are writing this, what we need to do, because as you can see here, right, it will store as a array, right? So it will store the pair of this, right? Multiple rooms pair will be there. There's no such data structure, so we'll use a array, right? And it will store end time and room number, right? As you can say, long array we have taken, right? So at index at 0, so both meetings are there if both are equal, right? If both are equal, what we are comparing, if both are equal, then we'll compare it, right? Compare, long dot compare A at 1 and B at 1. Which room index is the smallest one? Let's suppose this A first having index is 0 and this one having index is 2, right? Which one is bigger one? This is, if this is, let's suppose 3 we have, and this is 1 we have, which one is the smallest one? 1 we have a smallest one. So what we will do, we'll take this one, okay, and we'll store it. Okay, and then we have our this meeting count, right? We'll take the meeting count for each room, that we'll understand. We'll keep track of how many meetings each room has stored, right? And for hosted, you can say, not stored, hosted. So we'll keep track of you can say how many meetings each room has hosted, that will stored here. So let's suppose we'll start from we'll go for all the meetings. We'll iterate all the meetings now. Okay, now understand that we will use this one meeting count, right? After that, we'll iterate for all the meetings. Can we say that? So one at a time, we'll get the meeting here, right? So one meeting having the start and end. We'll find meeting at 0 is start and end is at 1. Then we'll find the duration. End minus start, we'll get the duration, right? So this we will use if we have to delay the meetings, right? It is very necessary, right? If the meeting is delayed, means we want to reschedule it, right? So what we will do, first we'll check. What we will check, if any rooms are free now before this meeting starts. Before this meeting start, as you can see, right? Means busy room is empty. If it is not empty, busy room is not empty, means there should be some meeting is going on. And we say that it should not be empty. Then we'll say busy room dot peak. We'll get the peak value from here. Okay, and we'll check 0, means we'll check the start time, right? So at 0, what we have, the end will be there, right? At the end time and its room number, right? We were storing on the where, at the busy room. Can we say that? So this is your A at 0. Let's suppose this is the meeting that is already on the busy one, right? So we'll check its value. Let's suppose it is coming 5, right? We have taken the example, right, in which another meeting was 1 and 5. First meeting was at 0 and let's suppose 10, right? So start at 0 and ends at 10. Another meeting start at 1, let's suppose, and ends at where? 5. Can we say that? So another meeting it will come, let's suppose 2 and 7, right? Let's suppose another meeting. So its duration is 5. Can we say that? And this meeting that is on the peak, these twos are already occupied, right? So the busy room will store this 5, right? It is represented as 5, right? And the room number is 1, not 0, right? Room number 0. So we'll check with this one, the start. When it gets start at 2, so we'll check like this. Is it true or false? If it is less than equal to this, that is we are using here. Okay, so this is true or false. If it is true, let's suppose the start is bigger, you can say bigger, and this is smaller. That is not happening, right? So we'll not go here, right? We'll not assign this one. Means it should be like 2 and 5, right? Then we'll assign here. We'll get that room and we'll store them. Understand? If it is, let's suppose if it is getting short, right? Let's suppose it will go, it is getting finished at where? At let's say it start at 0 and finish at 1. Can we say that? So 2 is less than this, so it is getting assigned. Otherwise it will not get assigned. So this is happening here. Similarly, we'll check the available room is empty or not. If it is not empty, right, we'll get the room here. I hope you understand this one, right? Means we will check the room. We will check the room. If rooms are now free before this meeting starts, right, we'll check the end time is less than the start time. It's free now, and then move it to the available room. Then we are talking about this one. Means we will check if the room is free room, and we'll pick the smallest number, right? So we'll get the room here. Room equal to available rooms dot poll, right? Then we'll check the busy room. We'll do what? A start and duration. A start and duration, and this is your room. So what we are doing, this is the start. Let's suppose this is the start at 2, and duration was what? This duration is 5, right? So we'll do 5. So this becomes 7. And what is the room number? Room number is 1. So room number 1 we will assign like this. We'll add onto the busy room. So busy room get added now. Understand? When it is available, that time we'll keep our entries like this and we'll store here. So meeting count will get increase at this room index. So now meeting room first off is already handle 1. Now it is getting handle another one. So for meeting room, let's suppose room number 1 we have count is 2. Like this we'll store. Not like this. Let's suppose this is our index 1. So we'll store like this. Okay, we are doing here. Means if there is a free room, pick the smallest number, right? And we are doing poll, right? We'll get the smallest one, because at the top the smallest room number will there, right? And then we'll schedule the meeting by doing plus start plus duration. You will get the scheduled meeting time, start time, and we'll push the room to the busy room with a new time. That is our new time, that is called 7. I hope you understand, right? Now what we are doing here, let's suppose we have to do the delay meeting until the earliest room becomes free. It means if no room is free, we will delay the meeting, correct? And we'll wait for the room that becomes free first. We'll schedule the meeting that starting from its end time, and we'll keep the original duration, and we'll add the room back into the busy room with the new end time, and we'll keep incrementing the meeting count, right? So you will get the earliest time, you will get the earliest time, right? And you will get the end time, right? Can we say that? Give me 1 second, right? And you will get the room count like this, and you will add the new start and duration similar to that, right? You have to reschedule that similarly. So we'll have our like we have to actually what we are doing here, we will check the earliest time, right? If the delay is happening, remember the first meeting also ends at 10, right? And another meeting that we have seen 5 to 10 we have done, right? 5, yes, 7 to 10, yeah, 5 to 10, let's suppose. So both ends at 10, right? It means what we have here is let's suppose room number is 0 and room number 1, correct? Two meeting rooms were added there, right? And we have to use the another one that we have 3 or 4 something there for 1 hour, right? In that case we have to find what the earliest one, right? So we'll take from the busy room dot poll will do, and we'll get the this one, and we'll find our new start when the new start will happen. So new start plus duration, that duration will take, right? And we'll find the room number from here, and we'll add onto here, and we'll increase the meeting count. Means if no room is free, means both are occupied, this one and this one both is occupied, means we have to delay it, means we need to delay it, right? So we have to wait the room that becomes first free, either this will get free or this will get free, right? And we have to schedule the meeting starting time from its end time. So its end time is 10, both end time is 10, so we'll take 10, correct? And then the duration, what is the duration? Plus 1, right? So we'll say 10 to 11, right? That we have seen. We'll keep doing that until we'll get the room back from the there. Okay, and we'll add into the busy room after getting this. So you adding the busy room, and we'll increase the meeting count. Now what we need to do, so now after that we'll do what we'll do, we'll after that all the meeting are scheduled, right? Now we'll scan the meeting, right? We'll go for the room, right? We'll find the max meeting, what is the max meeting happen in which room, right? We'll scan the meeting count, right? And how we are going to do, we'll check this is the number of rooms we have. We'll check the meeting count at I, what is the max count is there, right? We'll get the max count like this, and we'll find the result room, right? And if the max count is greater than the current max count, right, we'll update it like this. Okay, and we'll find the result room, and we'll finally will return the result room. So this is the smallest room number, right, that we will return it. Okay, so I hope you understand, right? If you have any doubt in this video, please let me know in the comment section, and thank you for watching this video. And if you have any suggestion, please put me in the comment box, and